Good afternoon, guys. Good afternoon, guys. Okay, guys, we will start a minute to join. Okay, today's concept is the addresses in 3-address code. Briefly, we will see an overview of addresses in the target code. In the target code, how the addresses will be handled. That is our today's concept, addresses in the 3-address code or the target code. In this topic, we will discuss how names in the intermediate representation, how the names in the intermediate representation can be converted into addresses. Okay, we will discuss how the names used in the intermediate. IR means intermediate representation. IR stands for intermediate representation. How the names used in the IR can be converted into addresses in the target code. Okay, in this topic we have to discuss how the names in the IR can be converted into the addresses in the target code by taking a sample procedure calls. We will take simple procedure calls and return statements, and we will identify how the names in the 3-address code. For example, we have T1 is equal to A plus B. 3-address statement. Here A is a one variable, B is one variable, T1 is one variable. How these names A, B, T1 are converted into addresses. Thus, we have to see under today's class by taking the simple function, by taking simple procedure calls and return statements. We will identify how the names are converted into addresses. Okay, in static memory allocation, how the names are converted into addresses. In stack memory allocation, how the names are converted into addresses. We will see that one. Both in case of static memory allocation, how the names are converted into addresses. In case of stack memory allocation, how the names are converted into the addresses. That we will see in the previous class. Okay. Generally, the logical address space which is given to the program is divided into 4 parts. Already we have seen in the runtime environments we have seen. Okay. Runtime area, which is the runtime storage which is given to the program, is divided into 4 parts. Okay. For executing program, the OS will allocate some space, some logical address space will be allocated to the program for execution. That allocated space is called the runtime storage. Generally, the runtime storage is divided into the 4 parts. Already we have seen code area, data area, heap memory, and the stack memory. 4 parts we have: code area, static data area, heap memory, and the stack area. Sorry, stack memory. Those are the 4 parts which are divided. Okay, the first area in the runtime storage is the code area that holds the executable target code. Clear? A statically determined area code. The first part of the runtime storage is the code area that holds the executable target code. The size of the target code can be determined at compile time. At compile time itself, the size of the target code is determined, and that predetermined target code is stored in the code area. The first part of the runtime storage is the code area which holds executable target code. The second part is the static data area. The second part is a static data area that holds objects, global constants, etc. Okay, the second part of the data store runtime storage is the static data area that holds the global constants and objects that are generated by the compiler. The size of this global constants and compiler data can also be determined at compile time. Okay, the size of the global constants or the size of the objects generated by the compiler, etc. can also be determined at compile time. That means the data where placed in the static area can be determined at compile time. The size of the data that is placed in the code area can also be determined at compile time. Okay, the target code which is going to be placed in the code area size can be determined at compile time. Similarly, the size of the constants or objects which are going to be placed in the static data area can also be determined at compile time. The third part is the heap area. Okay, the third part is the heap area which is dynamically managed. The heap area is a dynamically managed one. It is a runtime area. Okay, while the program is running, whenever the objects want the XP, whenever the program parts want extra memory or want to deallocate the already allocated memory, that work can be done with the help of this heap area. Okay, for example, while the program is running, the object wants extra memory. The extra memory from the area. Similarly, while the program is running, the duty of one object is over. And that means memory allocated to the object will be freed. That freed memory will be added back to the heap area. If extra memory is required, that will be added given from heap. If memory is freed, that freed memory will be added back to the heap. Okay, heap memory is managed dynamically. Okay, heap will follow the dynamic memory allocation. Clear? The size of heap cannot be determined at compile time. Since it is a dynamically managed one, the size of heap cannot be determined at compile time. Why? Because some objects will ask for extra memory, some objects will free the memory. Okay, that's why the size of heap cannot be determined at compile time itself. The heap memory, this heap area of the runtime storage is a dynamically managed one. The fourth part is the stack area. The fourth part of the runtime storage is a stack area. Okay, what is the stack area contains? The stack area is also a dynamically managed one, which is used for holding activation records for the procedures we are executing in the program. For each procedure, an activation record will be created. Those activation records are actually stored on the stack area. Stack area of the runtime storage are used for holding the activation records of the procedures. Whenever a procedure is called, okay, the activation record will be created for the procedure on the stack. And after the procedure execution is over, that activation record will be taken back. It will be popped out of the stack. Whenever a procedure is to be executed, the corresponding activation record will be pushed onto the stack. And after the execution is over, the corresponding activation record will be popped from the stack. Okay, this stack area is also a dynamically managed one. This stack area is also a dynamically managed one. That means this area is also under dynamic memory allocation. Clear? Similar to the heap area, stack area size also cannot be determined at compile time. The size of the stack also cannot be determined at compile time like heap. Okay. See, when we come to the runtime storage, the runtime storage is divided into 4 parts: code area, static data area, heap area, stack area. Among these first 2 parts, code area, static data area, the size of the data that is going to be placed in code area and static data area can be determined at compile time, whereas the size of the heap and size of the stack cannot be determined at compile time. Just 1 minute, guys. Something has happened to the PPT. అయిపోయింది. Okay, that is briefly the code area, static data area, heap area, and stack area. Now, first we will go for the static allocation. We will briefly discuss about the static allocation. Then we will go for the stack allocation. Okay. To illustrate the code generation for simplified procedure calls and returns, we shall focus on the 3 address statements. Okay. Here, in case of the static allocation, we have to briefly see how names in the 3 address code will be converted into the addresses in case of static allocation. Okay, to understand that one, we will take the simplified procedure calls. We will take the simplified procedure calls and return statements for understanding the static memory allocation. Okay, we take simplified procedure calls and return statements in the form of 3 address code. To understand how names are converted into the addresses, we take a simplified procedure calls and return statements which are in the form of 3 address code. See, here we are taking a sample 3 address code statements. The first statement is call, callee, return, halt, action. Okay, the simplified code we are taking is the call, callee, return, halt, action. I think generally we have idea when we come to the functions. We have 2 types of functions are there: calling function, called function. Okay, what is calling function? The function which is calling another function is called calling function. The function which is called by some other function is known as called function. Those are generally in our language we are using the technical names: calling function, called function. Here we are using the names. Here callee means called function. In our language, in our C language, we have the called function. Here we are calling that one as callee. Callee means in our language called function. Here called means in our language calling function. In the C language we have calling function. Here we call it as a called. C language we have called function. Here we call it as a callee. Those are the technical names here we are using. Don't get confused with that. Okay. Here we are taking first call, callee. That means call the called function. The meaning is call the called function. Return, halt, action. Okay. This action is after this function is over. The remaining statements is called the action, which is a placeholder for the other 3 address statements. This action has nothing. Here action means the set of remaining statements after the function is over. Whatever the set of remaining statements, that is the action part. Okay, whenever the function is over. Here we are taking, for understanding the static allocation, we are taking the following sample 3 address code, which contains a call to the called function, call, callee, return statement, halt, and the action. The action is nothing but the set of remaining statements which are to be executed after the function is over. Okay, so action has no role at all. Action has separately no role. This is the other set of statements. The size and layout of the activation, how we want to execute this function. The activation record must be created for the function. Okay, the size and layout of the activation records are determined by the code generator, who will determine the size and layout of the activation records. Layout means it's a structure. How many fields will be there in the activation record? That is called the layout. The size and layout of the activation records are determined by the code generator with the help of information about names stored in the symbol table. By taking the help of names which are stored in the symbol table, okay, the information about names which is stored in the symbol table, this code generator will determine the size and layout of the activation records. Okay, here first we will discuss about the return address in an activation record. Okay, on a procedure call, first we will discuss about the statement, then we will go for the call calling in this one. Okay, in this example, first we will discuss about the return statement, then we will go to the discussion about the call calling. For our convenience, we assume that the first location in the activation record holds the return address. For our convenience, here we are assuming the return statement is always stored in the first location of the activation record. The first location of the activation record will store the return address. We are assuming like that for our convenience. Okay. We are taking sample function. The size and layout of the activation record for this function will be determined by the code generator with the help of symbol table. Symbol table contains information about the names. With that information about the names which are stored in the symbol table, code generator will identify the size and layout of the activation records. Okay, here we will first discuss about the return address, then we will discuss about the calling the other functions. For our convenience, here we are assuming that the first location in the activation record is the return address. The first location in the activation record holds the return address. Clear? Here we will consider the simplest case of static allocation. Okay, in the static allocation, how can we represent that code? That is, we will see. When we take the statement call callee statement, okay, what is the meaning of this call callee? The call statement is nothing but calling the other function. Okay, whatever the called function we want to call, the statement call callee indicates is the intermediate code that can be implemented by a sequence of two target machine instructions. The statement call callee can be implemented internally by two machine instructions. Okay, in the machine code, sorry, in the intermediate code we have the statement call callee. We have the statement call callee. That call callee can be represented in the machine code. How that statement can be represented means it is represented in the by two machine instructions. The call callee can be represented in the machine code by using two instructions, store and branch. By using the help of store instruction and branch instruction, that statement call callee can be implemented. We can implement that using two statements. First statement is store static area hash here plus 20. Second statement is branch callee dot core area. Okay, store callee dot static area, branch callee dot code area. By using these two statements, machine instruction, by using these two machine instructions, the pre-address code call callee can be implemented in the machine code like this: st call dot static area, st call dot code area hash here plus 20. Okay, now we will briefly see what is the meaning of this instruction, what is the meaning of this instruction. So first thing is the three address code statement is call callee. How the three address statement call callee is represented in machine code means, in machine code it is represented with two instructions, store, branch. Okay, the two machine code instructions which will replace this three address statement call callee is store callee dot static area, branch callee dot code area. We will discuss about this one now. What is the store instruction will do is, the store instruction saves the return address at the beginning of the activation record for the callee. Okay, here what it will do is, this store will do is, it will store the return address at the beginning of the activation record of the Kali. For the activation record of the function Kali, it will store the return address at the first location of the activation record of Kali. And branch BR transfers the control of the target code to the procedure of Kali. Okay, what is the meaning of this one is, here what will happen is, first the store, okay, it will store the return address, whatever the address of the return statement, the return address will be stored in the ST. Okay, the ST instruction will store the return address of this Kali function, and branch instruction will transfer the flow of control to the Kali function, to the Kali function. Here Kali function means in our language called function. Clear? What is happening in those two lines is, the store instruction saves the return address at the beginning of the activation record for Kali, and BR transfers control to the target code for the procedure Kali. Branch will transfer the flow of control to the target code for the called procedure Kali, and store will store the return address at the beginning of the activation record of Kali. Okay, here the attribute Kali.static area. Before and what ledandy. Here the attribute Kali.static area. What is this attribute indicate? Kali.static area attribute is a constant that gives address of the beginning of the activation record of for Kali. Mana return address ekkada store chesukuntunnamo, we are planning to store the return address at the first location of the activation record. At the beginning of the activation record, we want to store the return address at the beginning of the activation record. My activation record lo first location manaki ela telustundi ante, this Kali.static area is a constant that gives address of the beginning of the activation record of Kali. A Kali function at activation record lo first location manaki ela vastundi ante, this attribute Kali.static area represents address of the first location of the activation record. Clear? Kali.code area, what is this statement? Kali.code area indicates, this Kali.code area is a constant referring to the address of first instruction of the called procedure Kali. Clear? This attribute Kali.code area, the Kali.code area indicates the address of the first instruction of the function Kali. A function Kali lo unnatuvanti first instruction edaithe undo dani address indicate chestundi. It is a constant referring to the address of the first instruction of the called procedure Kali in code area. In code area. Clear? Code area lo unnatuvanti code area ante function Kali lo first statement edaithe undo dani address ni evaru indicate chestante, the attribute Kali.code area indicates address of the first instruction of the Kali ante em ledandi. Kali means in our C language called function. కొత్తగా మనకు కన్ఫ్యూజ్ అవుతుంది. Kali means called function. ఇక్కడ కాలింగ్ ఫంక్షన్ ఏమో నార్మల్ గా కాల్డ్ అంటాము, కాల్డ్ ఫంక్షన్ అంటాము. కాలింగ్ ఫంక్షన్ వచ్చేసి కాల్డ్ ఫంక్షన్ ఏమో Kali అంటాము, CALLE. ఓకే, టెక్నికల్లీ ద నేమ్స్ ఆర్ డిఫరెంట్ బట్ ద కాన్సెప్ట్ ఈస్ సేమ్. Clear అండి? What is this Kali.static area means? It is a constant giving address of the first location of the activation record. Kali.code area gives the address of the first instruction of the procedure Kali. Demo activation record lo first location Kali.static area. This code area demo Kali.code area will gives the address of the first instruction. Address of the first instruction of the called procedure Kali. My hash here plus 20 undi. Manaki inka andulo we have the hash here 20. Hash here is indicates the address of the current instruction. The hash here indicates address of the current instruction. That plus 20 is the memory occupied by the current instruction. In our example we have taken 20. General మన example 20 అని తీసుకున్నాము. General గా ఏంటంటే current instruction stage memory occupied, that is indicated by the value 20. Hash here plus 20. Hash here indicates address of the current instruction, currently which instruction is going to be executed, and this 20 is the bytes occupied bytes occupied by the instruction. Okay. Finally, what will happen is the code for the Kali will be executed after the Kali function is over. The return statement will return back to the calling procedure. Okay, it will come back to the calling procedure. After coming to the calling procedure, what will happen? If there is no other calling procedure for this calling procedure, finally halt will execute. అంటే ఎలా ఉంటుందండి, మెయిన్ ఫంక్షన్ ఉందనుకోండి, మెయిన్ ఫంక్షన్ will call function 1. Main function will call the function 1. Function 1 execute అయిన తర్వాత ఏమవుతుంది? It will return back to the main function. The function 1 will be returned back to the main function. Since main function is the first function, ఇంకా main function కాల్ చేసే వాళ్ళు ఎవరు లేరు కాబట్టి main function will execute the statement halt. Main function ఏం చేస్తుంటే halt statement ని కాల్ చేసి it will return control to the operating system. అండ్ జనరల్ గా ఎలా ఉంటుందండి, main function is calling function 1. Function 1 is calling function 2. Main function is calling function 1. Function 1 is calling function 2. So what will happen after function 2 is executed? The control will be returned back to the function 1. After function 1 is over, the control will be returned back to the main function. When we come to main function, there is no other calling function for main. Nobody is calling the main function. It is the first function itself. So what will happen? The main function will call the statement halt. Will execute the statement halt, which will return the control to the operating system. Okay, the main function will transfer the flow of control to the operating system. This is briefly the static allocation. See here what will happen is call calling. That means, okay, whenever a function, main function is called inside the main function will call function 1. That is the this call calling. Main function is the operating system will call the main function. Main function will call the function 1. After function 1 is over, it will return back to the main function. When we come to the main function, since it is the main function, it has nothing to return. Main function will not return anything. So what will happen? Main function will call the statement halt. Since there is nothing to return, simply main function will call the statement halt. If the main function call the halt, what will happen? The control will be transferred to operating system. Clear? So, for example, we have main function is calling function 1, function 1 is calling function 2. So, whenever main function is executed, the first statement is call F1. Immediately, the control will be flow of control will be transferred to function F1. Again, function 1 have the same syntax. Okay. Function 1, the first statement in the function 1 is call F2. So again the control will be transferred to the function F2. Inside the function F2, after all the work is over, return statement will execute. The control will be returned back to the function 1. Inside the function 1 also, the return statement will execute and the control will be returned back to main function. Inside the main function, since it is the first function, nobody is calling main function, so it has nothing to return. So what it will happen is, instead of return statement, it will execute the halt statement. It will execute the halt, and what will happen here is the main function will be executed and the control will be transferred to the operating system. The flow of control will be transferred to the operating system. That is what is happening in the static allocation. Clear? Call, return, halt. This action is the statements which will be executed after the function. Function అయిపోయాక ఏమైనా స్టేట్మెంట్స్ ఉన్నాయనుకోండి, those are executed with the help of this action that is indicated by this action. Clear? When we come to this call Kali, how the call Kali will be converted into machine code means that 3-address code call Kali can be represented in 3-address code in machine code like this. In machine code, that statement call Kali can be represented with 2 instructions: store Kali.static area, branch Kali.code area. Okay. In case of static allocation, how call Kali can be represented means store Kali.static area, branch Kali.code area. What is this Kali.static area indicates? Generally store instruction. Here the store instruction will store the written statement, written address in the first location of the activation record. The store instruction will store the written address in the first location of the activation record. Okay. How it will know the first location of the activation record? That information about the first location in the activation record is given by this Kali.static area. The attribute static area will give the information about the first location of the activation record. After this Kali.static area gives information about the first location of the activation record, store will store the written address in that location. Now, what is this Kali.code area? Branch Kali.code area. The branch instruction will transfer the flow of control to the Kali function. The branch instruction will transfer the flow of control to the Kali function. Clear? And when the flow of control is transferred to Kali function, how it will understand what is the first statement? Okay, who is the first statement in the Kali function? To understand that one, this Kali.code area. This Kali.code area is an attribute which gives the address of the first statement in the Kali function. The address of the first statement in the Kali function is given by this attribute Kali.code area. Clear? Kali.static area gives address of the first location of activation record to store the return address. Kali.code area gives the address of the first statement of the Kali function for execution. Here hash here plus 20. Hash here indicates the address of the current instruction. This 20 indicates the how many bytes taken by the current instruction. Here there is no specific reason for 20. A sample value of 20 has been given. It can be 15, 20, 30. Generally depending on the size of the current instruction, that much number of bytes will be allocated. After that one is over, after Kali function is over, the control will be written back to calling function. Okay, if the calling function still have another calling function, again the control will be written back to the first calling function. If the calling function has no other calling function, if no other function is calling this current calling function, then all statement will execute and the flow of control will be transferred to the operating system. This is briefly about the static allocation. Okay, static allocation. What is happening in the static allocation? We are taking a sample code only. We have taken how procedures are executed and how procedures will return value back to the calling procedures. A sample code we have seen here. Next, the same thing in case of stack allocation. Okay, how simple procedures are executed in case of stack allocation. We have seen simplified procedures in case of static allocation. Now we have to see the same simplified procedure calls in case of stack allocation. Generally, the stack allocation is the dynamic memory allocation. So here the memory allocation is not a fixed one. That's why the addresses generated are the relative addresses only. Static allocation can become stack allocation by using relative addresses for storing of the activation records. Static allocation can be converted into the stack allocation by using relative addresses for storage in activation records. In case of stack allocation, for the addresses in the activation records are only relative addresses. Here the addresses that are in the stack allocation for the addresses of the activation record that are given by the stack allocation are only relative addresses. Why we are calling them as relative addresses means generally the activation record will enter into the stack only when we want to execute the procedure. After the execution of the procedure is over, its activation record will be popped out. The activation for the activation record memory, stack memory will be allocated only when we want to execute the procedure. When it is the time to execute the procedure, then only its corresponding activation record will be loaded into the stack memory. After the execution is over, corresponding activation record will be popped out. That's why The addresses are not standard addresses. The addresses are only relative addresses. In case of static allocation, the addresses given to the activation record locations are static ones. That means they will not change. But here the addresses may be changed. First time they are loaded into the stack, some addresses will be given. Second time when they are loaded into the stack, some other addresses may be given. Okay. The addresses here which are assigned for the activation records are relative addresses only, not the permanent addresses. Clear? In stack allocation, the position of the activation record for a procedure is not known until runtime, as I told you. In case of stack allocation, the position of the activation record for a procedure is not known until runtime. Runtime lo a procedure avasram vachedaka kuda manaku teliyadu activation record yokka procedure. What is the position of the activation record for a procedure? That's why there is no permanent addresses for the locations of activation record. Only we will have the relative addresses. Okay. Generally, the activation record is stored in your registers. Okay. In case of stack allocation, we use the registers. The activation records are stored in registers. Since they are stored in the registers, the words in the activation record can be accessed as offsets from the value in this register. So the activation records may stack memory generally they will be stored in the registers. And how can we calculate the addresses means? Only we will know the starting location. Basing on the starting location, we will calculate the addresses by using offsets. Okay. The position of the positions in the activation record will, the position values in the offset activation record can be used as offsets. అంటే మనకి array లాగండి offsets activation record లో, for example, if you take the activation record, see, if you take an activation record like this, okay, since the activation record does not have relative addresses, okay, the positions of each word in the activation record will be used as offsets. Here the position of the value is 1, 2, 3, control link is 3, access link is in 4, machine status is in 5, local data is in 6, temporaries are in 7. Okay, the numbers we are giving to each words we are storing in the activation record or can be used as the offsets. Only we will have the starting address will be there. After knowing the starting address, we can calculate the address of the remaining words in the activation record using that offset. For example, it will give the address of return value, only the first address of the first be given. How to get the address of the next parameters? If the address of value 2024. Okay, 2024. How can we get the address of actual parameters? Starting address is 2024 plus offset of the actual parameters. If the offset means it's a serial number. If the offset of the actual parameters is 2, then 024 plus 2, that is 2 is the address of actual parameters. Next, how can we get the address of controlling? Address of controlling means starting address is 2024, and its offset is 3. That means 2024 plus 3, 2027. In that way, we can get here. The positions are viewed as the offsets, calculate the addresses. Only the remaining addresses will be calculated using the positions. Using the position as the offset values. Okay. The type of addresses and text addressing mode is convenient to for this purpose. Okay. Indexed addressing mode is more convenient for this one. Why? Because indexed addressing mode is similar to that of arrays. Okay. Index values are used as offsets. The starting address will be given and indexed values are used as offsets so that we can easily calculate the address of the remaining locations. That's why indexed addressing mode is best for this one purpose. For our convenience, if you point one, the relative addresses in an activation record can be taken as offsets. Okay, from any known position in the activation record. Activation record on the positions, we can take offsets. Okay, to calculate the relative addresses. For convenience, we should use positive offsets only. Generally, for our convenience, we will take positive offsets only. That means positive numbers are used as offsets by maintaining a register SP. Stack pointer. SP means stack pointer. Okay. By maintaining a register SP, a pointer to the beginning of the activation record on the top of the stack. Okay. A stack pointer, a register SP will be there. SP is a stack pointer which indicates beginning address of the activation record. The beginning address of the activation record is known to this stack pointer. Okay. SP is a register which is a stack pointer that contains beginning address of the activation record. SP will have the beginning address, and by using the offset values and the SP, we can calculate the address of any value in the activation record. Address is known is available in the stack pointer, and the remaining addresses can be calculated using the SP. For example, this is the activation record. It contains some fields like an address for actual values, temporary values, like that. The offsets are like this: 0, 1, 2, 3. The first address of the first location is 2024. Okay. Stack pointer contains this 2024. SP contains 2024. How to calculate the address of the second one? Address of A is starting address 2024. How can we get the address of B in the activation record? The offset value is 1 and the stack pointer contains 2024. So the address of B can be given as SP plus corresponding offset value SP plus 1. Similarly, how can we get the third part of the activation record? Stack pointer plus 2, where stack pointer contains the beginning address. The beginning address is maintained in a register called stack pointer, which contains the first address. And to get the remaining addresses, we use the positive offsets. By the help of the offset values, we can get any any address of the activation record. Any address of the activation record can be obtained here. Can be obtained here. When a procedure is called, the calling procedure increments SP and transfers control to the called procedure. When a procedure calls occurs inside the procedure, whenever another procedure is called, the call procedure will increment the stack pointer and transfers the control to the called procedure. After the called procedure is over, again SP will be decremented and control will be transferred back to the calling procedure. A function call the stack pointer will be incremented and control will go to the called procedure. After the called procedure is over, again stack point is decremented and control will come to the back to the previous one. Clear? That is the thing. After control returns to the calling function, we decrement stack pointer, thereby deallocating the activation record of the called procedure. Clear? అంటే ఈ సిచ్యువేషన్ ఎలా ఉంటుందండి? How this situation will be means? This is the activation record of function 1. Continuously, this is the activation record of function 2. This function 1. This function 2. Okay, the offset values are 0, 1, 2, 3, 4. Continuously, here we have the offset values 5, 6, 7, 8, 9. Now, initially the stack pointer contains the address of function 1. SP is equal to 2024. Okay. Inside the logic of function 1, internally function 1 is calling function 2. Function 1 is calling function 2. Okay, whenever we start executing function 1, this function 1 is calling function 2. Whenever function 1 calls function 2, the calling function calls called function, what will happen is the stack pointer is incremented to go to function 2. Stack pointer is currently 2024. It will be incremented until it reaches the function 2. Function 2. So the stack pointer will come to here. 2024 plus 5. So the stack pointer will contain the starting location of activation record of F2, that is 2029. Then after function 2 is completed, again stack pointer will be decremented to come back to function 1, 2024. Function starting of 2024, which is the starting location of activation record of function 1. Eప్పుడైతే function 1 function 2 కాల్ చేసిందో the stack pointer is incremented until it reaches the first location of F2. Clear? By using stack pointer, it will do work on the function 2. After function 2 is over, again stack pointer is decremented to come back to first location of F1. Okay, that is what is happening. Clear? When a procedure call occurs, the calling procedure increments stack pointer and transfers control to the called procedure. After control returns to the calling function, we decrement the stack pointer. Malli eppudaithe called function ayipotundo, the controller will return back to the calling function. Then we decrement the stack pointer, thereby deallocating memory record of the called procedure. Called function ayipogane the stack pointer will be decremented and the memory given to the activation record of called function will be deallocated. That is what is happening in the stack allocation. Clear? In case of stack allocation, what is happening is generally stack pointer will indicate the main function, function 1, function 2, 3 functions anukondi. Initially stack pointer indicates the first location of activation record of main function. It will indicate the first location of activation record of main function. First location of main activation record of main function. Inside the main function, whenever main function calls F1, immediately the stack pointer will be incremented to reach F1. The stack pointer is currently here. It will be incremented to reach F1. Then F1 execution will be started. If F1 is again calling F2, then what will happen is again stack pointer is incremented to reach F2. After F2 is over, the stack pointer is decremented and to reach F1, and the control will be transferred from F2 to F1. Whenever the control is transferred from F2 to F1, immediately the memory allocated for F2 will be deallocated. Immediately this memory will be deallocated. Next, after F1 is over, again the stack pointer is decremented to reach the main function. The control will be transferred from F1 to main function. After F1 work is over, again the memory allocated for F1 will also be popped out of the stack. The activation record of F1 will be popped out of the stack. The activation record F2 is popped. Now F1 is popped. Okay. After main function is over, since it is the main function, it has no calling function. So the control will be transferred to operating system, and the memory allocated to main function is also removed from the stack. Main function activation record is also removed from the stack, and the control is transferred to the operating system. That is what is happening here. Also same thing in the form of the entire operation is happening in the stack. The entire operation is happening. Okay. Here the first location of the activation record is maintained by the stack pointer. The stack pointer will move from function 1 to function 2, function 2 to function 3 like that. And if you want, it will move in the return also. In the return also, it can be moved. In any direction, it can be moved, either forward or backward. See, initially load stack pointer. Okay, the initial 3 address code, the 3 address code can be converted into the instructions as first load SP, load stack pointer. Okay, hash stack start. Okay, load SP means the stack pointer is loaded with the starting address of the activation record. The starting address of the activation record of first procedure is loaded into the stack pointer. The starting address of activation record of first procedure will be loaded into the stack pointer. That means in our program, the first location of the activation record of main function will be loaded into the stack pointer. Clear? It will be loaded into the stack pointer. After the entire work is over, halt. Okay, that will halt will execute after some time. So initially stack pointer is loaded with the first location of activation record of first procedure activation record load అవుతుందండి. Clear? Whenever a function calls another function, whenever a calling function calls another function, what will happen? మనం ఏం చెప్తున్నాం, ఒక ఫంక్షన్ కాల్ చేస్తే ఏమవుతుంది, స్టాక్ పాయింటర్ విల్ బి ఇంక్రిమెంటెడ్, స్టాక్ పాయింటర్ ఇంక్రీజ్ అవుతుంది. టు రీచ్ ద సెకండ్ ఫంక్షన్ ద స్టాక్ పాయింటర్ విల్ బి ఇంక్రిమెంటెడ్. Clear? See, what are the 3 address code statements for increasing the stack pointer and to transfer the control means add sp comma sp. Okay, the stack pointer previous value will be added to this one. The stack pointer will be incremented. Add sp comma sp hash caller dot record size. Next, the stack pointer value will be stored finally branching. See what will happen. What is the meaning of this one? What is the caller dot record size contains? The caller dot record size indicates size of the activation record. The size of the activation record is indicated by the caller dot record size. And this add instruction makes stack pointer to point to the next activation record. Okay, whenever this is add sp comma sp, whenever this is executed with the help of caller dot record size. Okay, caller dot record size indicates the total size of the activation record. Okay, then what is this? With the help of the information of the total size of the activation record, this add instruction will move the stack pointer to first location of the next procedure. Generally, the stack pointer contains first location of the first procedure. Since the first procedure is calling second procedure, now the add instruction will load the stack pointer with at the first location of the address of the first statement of the second activation record. Clear? Then what will happen is, stack point load with initial address, next is to reach the second procedure. The add instruction will make the stack pointer to reach the second procedure. See, this is hash here plus 16. Here also the duty of the hash here plus 16 is, what is the meaning of that one? Hash here indicates address of the current instruction, and 16 is the how much memory is taken by the current instruction. Okay, hash here indicates the address of the current instruction, and plus 16 indicates the size of the how much bytes are taken by the current instruction. Okay, the store instruction will store the address pointed by the stack pointer. Whatever the address pointed by the stack pointer, the address will be stored in the by this ST instruction. Clear? Then at the calling function, after the side of called function, what will happen is the return sequence is also contains 2 parts. The return sequence also contains 2 parts. What will happen is after the called procedure is over. Okay, the called procedure whenever the called procedure is over, that flow of control will transfer to the calling function. It will call branch SP. Okay, branch SP instruction will be executed. After the call procedure is over, first it will call the branch SP, branch stack pointer. That means jumping of the stack pointer from the first location of the procedure 2 to first location of the procedure 1. It will call the branch SP. Whenever the branch SP is called, what will happen is subtraction of the stack pointer will be done. Okay, decrement of the stack pointer with the help of the instruction support. Subtract SP comma SP comma the record size. Here, basing on the size of the called function, okay, the stack point size will be reduced. Okay, the stack, that means what will happen here is in the return sequence, first branch instruction will call the stack pointer, then the subtract instruction will subtract will decrement the stack pointer to the first location of the procedure 1. Will be decremented to the first location of the procedure 1. See, what is happening here is, for example, we are taking an activation record like this. Function 1 is there. Function 2 is there. The offset values are 0, 1, 2, 3, here 4, 5, 6, 7. Like that we have. Here initial starting address is 2024. This is SP, starting value of SP. Load first location address to SP. This is happening. Load SP. Then SP is equal to 2024. After some time, F1 is calling F2. That means the stack pointer should come to this address. What is the address of F2? F2 address ఎంత? What is the address of F2? Its offset is 4. So the general address of F2 is, first location of F2 address is 2028. The address of F2 is only offset 4 కాబట్టి 2024 plus 4 2028. Clear అండి. SP is equal to మనకి ఇనిషియల్ గా 2024 ఉంది, ఇక్కడ లోడ్ అయింది. SP is equal to 2024 లోడ్ అయింది. Whenever the procedure is F1 is calling F2, కంట్రోల్ F1 నుంచి F2 ట్రాన్స్ఫర్ అయింది కాబట్టి స్టాక్ పాయింటర్ కూడా ఇక్కడికి రావాలి. అది ఎలా వస్తుంది అంటే విత్ ద హెల్ప్ ఆఫ్ దిస్ యాడ్ SP, SP కాలమ్ డాట్ రికార్డ్ సైజ్. Okay, whenever this statement is executed, SP will come from 2024 to 2028. అది ఎలా వస్తుంది అంటే ఫస్ట్ కాలింగ్ ఫంక్షన్ యొక్క సైజ్ అంతా, వాట్ ఇస్ ద సైజ్ ఆఫ్ కాలింగ్ ఫంక్షన్? 1, 2, 3, 4. The size of the calling function is 4. So for the value in the SP, 4 will be added. The size of the calling function added to the stack pointer 2024 plus 4, that is equal to 2028. Here, add instruction will increment the stack pointer to 2028. After that, it is incremented to 2028. The value 2028, it will be stored in the stack pointer. 2028 will be stored in the stack pointer. Add instruction will add that value 2024 plus 4, that is 2028. Now the value will be stored in the stack pointer. After 2028 is stored in the stack pointer, okay, branch instruction will call the callee.code area. The branch instruction will call first statement of F2. The first statement of F2 will be called by this branch instruction. That is what is happening here the first side. Whenever calling function calls the called function, the first location will be, which is in stack pointer, will be changed to first location of the second function with the help of add instruction and store instruction. Then the first statement of the second function will be called. After F2 is over, again what will happen after F2 is over? The flow of control will be branched from F2 to F1. Flow of control will transfer from F2 to F1. So stack pointer has to be reduced to 2024. Currently stack pointer is 2028. It has to come back to 2024. Again what will happen is this work is done with the help of subtract function. Here what will happen is previous current stack pointer value minus size of the calling function. What is the size of the calling function? 4. So 2028, current value of 2028 minus 4, that is 2024. Clear? That is what is happening here in case of stack. Okay. మళ్ళీ దీనికి ఏదైందండి? Okay, branch will jump, call the stack pointer for jumping. Okay, whenever the branch call the stack pointer for jumping, subtract operator will subtract the stack pointer with the amount of column record size. Calling function యొక్క record size entundo choose activation record size. That value will be separated from the previous current value of stack pointer, so that we will get the first location of the procedure 1. Okay, that stack pointer will move from first location of the second procedure to first location of the first procedure. That is the stack allocation. In stack allocation, how the control will move from calling procedure to called procedure. In case of stack, how it will be done. Okay, same concept how it is happening in the static allocation. In static allocation, how jumpings will be done from procedure 1 to procedure 2. In case of stack allocation, how the same jumpings will be done from calling function to called function to calling function. That is the today's concept. Okay, how it is identifying the addresses from calling function to called function to calling function. Briefly, this is the small concept of addresses in the target code. Clear, guys? ఇంకా 5th యూనిట్ లో ఒక స్మాల్ కాన్సెప్ట్ ఉందండి, సింపుల్ కోడ్ జనరేటర్. విత్ దట్ వన్ ఇంకొక క్లాస్ తోటి అవర్ 5th యూనిట్ విల్ బి కంప్లీటెడ్. మన 5th యూనిట్ కంప్లీట్ అయిపోతుందండి. గైస్, ఆల్రెడీ మీకు డేట్స్ తెలిసే ఉంటాయి. యూ గాట్ ద డేట్స్. నవంబర్ 11th నుంచి ఎగ్జామ్స్ ఉన్నాయండి మీకు. ఐ థింక్ నవంబర్ 11th నుంచి ఏమో. సో 2 సబ్జెక్ట్స్ అన్ని మళ్ళీ స్టార్ట్ చేయాలని చదవటం. మ్యాండేటరీ హీ విల్ కండక్ట్ ద ల్యాబ్స్ అండ్ ఎగ్జామ్స్. ఎక్స్టర్నల్ ల్యాబ్స్, ఎక్స్టర్నల్ ఎగ్జామ్స్ మ్యాండేటరీ కండక్ట్ చేస్తాడు. సో ఎవ్రీ వన్ మస్ట్ బి రెడీ to learn the concepts. Okay, exams ready avalsinde. Okay guys, again we will meet in the tomorrow class. Thank you.